All right. Well, I'm Mark Plaksin, and like Andrea said, feel free to ask questions or interrupt at any time. I'm not very formal, so interruptions and questions are welcome. We've been doing these what we call Tech on Tuesday presentations for maybe the past year, maybe every couple of months. We've been doing a presentation internally, and at Rock Eagle, we talked about it might be good to start doing some of these externally as well. So this is the first one of those. That's why it says version 7. And if you don't know, Athens Tech has an advertising campaign called Tech on Tuesdays, where you go learn about Athens Tech. And I just thought it was a good joke to steal their marketing. All right. So here's an outline of what I'm going to talk about today. First, I'm going to just cover automation and the fact that, well, it's great, and I also think that it's a requirement. And it's unfortunate, but making your life easier actually takes some time to get started, so I'll talk a little bit about that. We think Puppet is great and that it makes doing complex things easy. And then we use Noodle as our server database, so I'm going to talk a little bit about that because it's integrated with how we use Puppet. And then Puppet's not the only choice. You know, we love Puppet, and we think a lot of people would get a lot out of it, but there are plenty of other choices out there, and so I'll talk about some of those.
Okay, we've got a question in our chat room, and I'm just going to jump in here just for a second and respond to that person. So go ahead and keep talking, Mark.
All right. So after covering some of the other options, I'll show some complex Puppet examples and some of the things that we've been able to do with it, and then go back to some of the basic syntax, and then sort of end up with, you know, there are so many tools out there these days that it's sort of, I think, our responsibility to start using the automation tools as much as possible so that we can get more and more done. All right. All right, so hang in there, and hopefully this audio is going to work, and the advertising is not going to cause us any problems. Just a little video. So this is the problem. And yep.
Hey,
Sorry about the advertising. I've tried twice now to skip the advertising. No such luck.
Now, this is your last chance. If one piece of candy gets past you and into the packing room unwrapped, you're fired. Listen. Oh! Well, this is easy. Yeah, we can handle it, okay?
Can we start it back over, and I'll show you.
Oh, yeah. All right, sorry about that. Apparently, I failed.
All right, so guys, we'll hang out just a second. We're going to share our desktop, and then go back to Chrome. All right.
Now, this is your last chance.
There we go.
If one piece of candy gets past you and into the packing room unwrapped, you're fired. Listen. Oh! Well, this is easy. Yeah, we can handle it, okay? You're doing splendidly.
All right, so we saw that movie at VMworld, and it really hit home for me. That's where we were about 6 years ago when we had a new version of Vista coming in, and we had approximately 200 new servers that we needed to get installed in a hurry because of timing. The hardware got ordered after the new fiscal year, and it needed to be turned around very, very fast after it was actually delivered. So at the time, we spent a lot of time getting Puppet set up ahead of time before the hardware showed up, and then when it did show up, we spent approximately a day installing all 200 of the machines. So it really made a big difference for us. One other thing I want to say is that Puppet and automation will help you do things faster and let you do more. But even if you don't have a ton of machines that you need to work with, you know, we have a lot here, approximately 1,000 OSs total. But even if you've got a smaller number, automating will help out because it serves as documentation, and it helps in a lot of other ways that will hopefully become clear as I go through the rest of this presentation. I just wanted to point out that it's not only about scale. All right, so like I said, the problem is you can't really keep up, and it's also hard to repeat yourself over and over again. We tried really hard by hand to sort of manage our systems and make them all as identical as possible. And as hard as we tried, you know, we inevitably made some mistakes, some of which, you know, caused us to have to go back and redo work, or they caused problems, or if nothing else, they caused the need to fix them so that everything was the same, and that sometimes required downtime. So it wasn't ideal. Another thing that happened is, I guess this has been happening more and more recently, but in IT, more and more projects and computer and applications come along, and people want them up and running. And as much as we might want to talk about what our capacity is and how much we're able to get done all at once, we don't get to control it. So that's what I call the fire hose. Things are coming to us no matter what, and we need a way to handle them so that we're not just falling over or having to work around the clock to keep up. Peter, another guy on my team, points out that one of the things we tried to do was on our Unix machines, we were trying to make sure each user had the same UID on all of the machines. And even something that sounds simple like that, once we had 20 or 50 machines, eventually mistakes would creep in. So automation has helped a lot with that. So I like to say now that we sort of don't care how many OSs we have to run because we've automated almost the entire process. This little quote here I like a lot, you know, we can try and stand firm and tall like a tree, and then if the wind blows hard enough, we'll just get broken and knocked down. Better to be like a blade of grass so that you're flopping around in the breeze and you're able to sort of handle things without it being a big deal. This Tom Limoncelli, he is a very famous and good system administrator. He writes a lot and speaks a lot. And one of the things he said recently is that there's a clear distinction between tools and automation. Automation will eliminate a task so that a person no longer has to do it, and a tool is something that improves a manual task so that it can be done better or maybe faster. So, and some of these next slides show, I think that, you know, there's an evolution from doing it by hand to automation. So you can't always jump right into automation. Oh, and here it is, the next slide. So I think the evolution is you do it by hand, and you probably do it by hand a few times, and maybe a lot of times. And at some point, you get the idea that you should try and create a script or some kind of tool that you can run to repeat the process over and over. Maybe you write some documentation about the manual steps or about how to use the script, and eventually you realize the script needs some improvements, and maybe you put it in version control so you can keep up with your own changes, and you sort of repeat this process of trying to improve the script and make it more useful. And as much as you you can get a lot done that way, but at some point you're going to have some variance that creeps in. Maybe your script hasn't taken everything into account, and you're going to have some problems, or maybe you just don't actually run the script the same every single time. You've got some options. So at some point you're going to have some variance, and at some point it's going to cause you some trouble. Another thing that happens is you might need to make a large change where you get to this fork in the road where you're either going to start over with a new script because the change is big enough you can't really modify what you've got, or maybe you start to think about automation. And then automation is sort of a similar loop. You're going to improve it as you go along, but hopefully you're avoiding a lot of the pain of the variant creeping in and causing you problems. Now, I also think that once you've got automation going and some good tools, it makes it easier to make large changes, and we'll get to an example of that. Right, so the last step is to never stop automating. So we're currently using Puppet, which is a configuration management tool, but there's a lot more that we could be doing. And as I'll probably say several times, there aren't really any excuses anymore for not doing a lot of these things. It's kind of like web development and having pretty web pages that are responsive. There are so many free tools and libraries out there that if you're going to make a website, it really better look good, or else you're not really taking advantage of all the things that are out there. I think the same is true for automation. So we're doing configuration management now. Continuous integration is another big thing where currently we use Puppet to help us get our OSs installed and configured. Well, sometimes we make changes to Puppet and then we go test those on a small set of machines. Continuous integration is about whether you're making changes to your Puppet code or maybe an application. The computer will go off and, for Puppet, say, it might go install a VM and run it against your new Puppet changes and report back to you if there are any problems, or maybe even just let you poke around in it to make sure that everything looks okay. Continuous deployment is similar. It's about getting applications handed out. Currently, we add new things to our monitoring and stat systems, mostly by hand. That's another thing that more and more people are automating. And people are also starting to automate things like networking. VMware came out with something called NSX, which is designed to let you automate all of the networking components. And if you've got more of these things or all of these things done, you'll also get out of it, you'll need to somehow have recorded effectively the architecture of your systems, and you can draw pictures of what the systems look like and explore those. And yeah, the big companies are definitely constantly deploying. So it's, I think, something, there may be the extreme, but we can certainly head in that direction and a lot of progress. Another thing I think is true is that you can make your upgrades easier. Currently, a lot of times we will have a large downtime for a major upgrade. If everything was automated, you can imagine doing upgrades in a different way. Maybe you install a whole new stack that's running the new version. And when it comes time to upgrade, you have a short downtime where you basically copy, and hopefully pre-stage this copy as much as possible, but you copy, say, your database from the old stack to the new stack, you turn the new stack on, and that's a fairly quick upgrade compared to taking the whole thing down and upgrading it in place. It also makes it a lot easier to fail back and forth if something happens. All right, so what makes a good product or tool? I'm trying to use product here to refer to an automation product, whether it's free or commercial, and then tool is more along the lines of a script, something that makes things easier. So hopefully it will do the boring work for you. And one thing that has come up as we've talked about this is you shouldn't worry that if you automate things, you're going to lose your job or have nothing to do, or automation will let you accomplish more, sort of more with less, and then you will still have plenty of more interesting things to do, especially because more and more projects come along that will need to be automated. So hopefully your automation has a good community around it and is being actively developed. I think that helps a lot. And let's see. Another thing that has been helpful is if it has all kinds of interfaces. If it has a GUI and a command line interface and an API so that you can connect it to other systems, that helps a lot. And I think Puppet is one of those. And So one of the things that we've noticed with Puppet is that sort of as a byproduct of using it, it's hard for us to make big mistakes. So when you're just at the command prompt and typing, every once in a while, you're going to just make some sort of typo that, you accidentally delete a file or you cause some other interruption. So it's certainly possible to cause those same kinds of interruptions with a tool like Puppet, but it turns out that it just happens a lot less. And I think that's a sort of a testament to using tools. Another thing that, let's see, what am I trying to say? I guess when you're approaching things at a higher level, when you're using a tool like Puppet or some other automation tool, just the fact that you're taking that higher level view makes it harder to make mistakes. And I said this before, I'll say it again, it takes time to get these automation products and get tools up and going. And in the end, I think it's definitely worth it, but it can be hard to get started. When we first started using Puppet, we would often spend hours and hours telling Puppet how to do some task that we could do by hand in 15 minutes. And when we finally got to the end and it was automated, we would say, see how much easier this is? Just sort of as a joke to remind ourselves that it really is worth it. So it's a hard thing to get started, but hopefully once you get started, you'll start to reap some rewards fairly quickly. And then once you do get started, you hopefully get back some time, and it gives you more and more time to automate more and more. All right, so here is basically a quote from the Puppet website about what it is, and it was trying to demonstrate that Puppet sort of meets some of those requirements that I listed in what makes a good product. It's flexible and it's customizable, and it takes a declarative and model-based approach to IT automation, and part of what that means is this kind of lets you define things at a high level, like saying this machine needs to be a mail server, instead of saying all the many details that need to be typed in order to turn that machine into a mail server. At some point, you have to tell Puppet those details, but once you've told it, you can just tell it to make 50 more machines into mail servers instead of having to worry about the little details. Puppet lets you define the desired state of your infrastructure using a configuration language, and right, so Puppet is going to take the configuration language and turn it into what it calls a catalog, which is a list of things that are supposed to be configured on your system, and it's going to go out and make sure that they are configured that way. And then it does that over and over again. So if you accidentally say turn off a service, or if some service goes away, Puppet's going to go out there and sort of regularly enforce that desired state and set it back the way that it's supposed to. And it's definitely true that Puppet frees you to work on more challenging projects and with a higher business impact and ROI. So the too long didn't read version of why we love Puppet is we can have a fully installed VM with about 10 minutes worth of work. And currently, as I like to joke about, 9 minutes of that work is making DNS changes to get the new systems into DNS. We just recently bought BlueCat, and we're going to replace our DNS system with BlueCat. It has an API, so it's a good automation tool, and we're planning to automate the DNS part. So hopefully in approximately 1 minute worth of human work, we'll be able to create a VM. And in that same 10 minutes, or maybe 1 minute, once we've got our DNS automated, we can create 50 VMs. So we get to specify one time something like, hey, I have a new stack of banner machines, go install them, because Puppet already knows what it means to make a stack of banner machines. So we get to do that. Yeah, to specify once, install many. That's the short version. So one of the tools that we use to Puppet sort of forces you to define your OSs externally in one way or another. You can do it in the Puppet config, but once you've got more than a handful of machines, we'll use what they call an external node classifier. And we created one called Noodle maybe 5 years ago. And it lets us specify the project. Each of our machines is in it, and then we have some parameters that tell it what project that machine is for, and then what roles the machine has, like whether it's a database server or an application server or a file server, web server, that sort of thing. So we specify those things in Noodle, and then we have corresponding Puppet configuration that says, well, if you are a Banner database server, here's some configuration and some packages that need to be installed on the system. So Puppet will do it the same way every time. The Puppet config, as you'll see in a little bit, is very readable, so it serves as documentation. It needs to have either long scripts or just long sort of cookbooks on our wiki that said, here's how to make something like a Banner database machine. Now we don't really have that stuff at all. We look at the Puppet configuration if we need to know how things work. We use version control with our Puppet config, so whenever we make a change, we commit it into our version control system. And one of the nice things about Puppet is it has a little syntax checker. So we've got that hooked into our version control system. So if I make a change that has a syntax error, before it gets committed into Git, it will tell me, hey, you've got a syntax error. You need to fix that before I'm going to accept this change. Another thing we like about Puppet is it's fairly easy to extend. It comes out of the box doing a lot of things, and there are a lot of modules out there in the world now that allow you to do even more. But if you have something specific that it can't do, it's fairly easy to add some code to let it do that. So those last 3 points are about we have Noodle, and it interacts with Puppet. Puppet also interacts with Noodle, because as Puppet collects facts about our operating systems, we put them back into Noodle because we use that tool to query what's going on a lot. And then we've recently started using Logstash a lot, and we've also integrated that with Noodle. And that's something that's been fairly easy. So it's a good demonstration that having tools that are open and fairly easy to extend is very helpful. So this is a picture of a Logstash dashboard that is showing data from Noodle. So we've got a Noodle input that goes into Logstash, and then we're able to use Logstash to create a dashboard. So this particular dashboard is showing how many CPUs and RAM and storage we're using across all of our OSs. And towards the bottom, you can see these little magnifying glasses. If you were to click on one of them in Logstash, it would limit what's being shown to that specific project. So if we need to know what a project is using, the information is right there. So this is a good way to see how things can really come together and make things a lot easier. We get asked these kinds of questions a lot, and just with these tools, and a little bit of glue to hook them together, we're able to get these cool dashboards. We have something similar for our virtual data center, where we have the customers that we've got, how much we've sold, how much capacity we have on hand. So here's sort of a joke about how the Puppet config serves as a manual or as documentation. This XKCD cartoon is trying to say that tools that don't need a manual, they usually tend to solve problems. And the more manuals you have, or the more complex manuals you have, that might actually be about some kind of tool that is making the problem worse. Now, of course, that's maybe a little bit extreme, but I think it highlights how useful having something like Puppet configuration that implements, it serves as both documentation and implementation. All right, so I've mentioned Logstash. Logstash is a pretty cool service. We use it to put all of our system logs in it, and I did a presentation about it at Logstash. And if you're interested, I can send a link to that as well. And I did a Noodle presentation there too, so I can send those links if people are interested. So Logstash is fairly complicated or complex. It's running at 2 sites. It has 3 or 4 different parts. And we've got a production stack and a test stack for it, and maybe one day we'll have a development stack. So it's kind of complex, and we're in the midst of doing an upgrade from version 1.2 to 1.4, and there's really a lot of changes that are involved. So the next few slides I'm going to show how Puppet has made it a lot easier to get that rolled out. And like I said, the Puppet config serves as documentation, and it lets us do things the same way over and over, and it also helps with the upgrade problem. We've recently been talking about identity management here, and Glue is one of the companies that has some identity management services that you might buy, and they also have some open source version. But one thing I like on their website is they say with their Puppet recipe, they can deploy one or more instances of the Glue server faster than you can find a wiki page on how to build. So I think that's a very good demonstration of how much Puppet can help. It doesn't take long to find a wiki page. So this is what our Logstash architecture looks like. We currently, or before Logstash, we were running syslog-ng to collect all of our system logs in really two places, one per site. So the blue circles are the syslog-ng servers that already existed, and then Logstash is composed of basically all the rest. So in the middle, the green is our Elasticsearch cluster. It's 4 nodes, and it's at 2 sites, and all the data is at each site split up across the 2 nodes. So Elasticsearch is a really fancy full-text search engine that is sort of a default output for Logstash, and it works really well. But it is complex. It's a 4-node multi-site cluster data. So let's see, what's next? From syslog-ng, the blue circle, the next thing that's involved is Redis. So Redis is just an in-memory cache. So we run Logstash now on the syslog-ng servers to ship all the logs into this Redis cache, and there's one of those at each site. And then the Logstash indexer is really what does all of the work. It reads the logs out of the Redis cache and processes them, breaks them up into fields, and sends them into the Elasticsearch database. And then Kibana is the web front end. So it's the one that made the pretty dashboards we saw earlier. And we've also got that running at each site. And then we've got GTM, which is a geographic load balancer, in front of that. So you can see that it's fairly complex, not too terrible, but it's hard to do all of these details, or it would be hard to do all of these details by hand, especially more than one. So what makes this easy? We use Noodle to define the different servers that are in a new Logstash stack, their roles are, and then from there we already have some Puppet modules that cover sort of the base operating system. Those are the things that we want to have installed on every one of our Red Hat OSs. Elasticsearch is the company that makes Elasticsearch, Logstash, and Kibana the web interface. So they have some Puppet modules for deploying both Elasticsearch and Logstash. So we use those, which is helpful because we didn't have to create those. Part of what having a good community around the tool or your automation product lets you do. We already have some Puppet modules for Apache and one for Tenchi. Tenchi is a log scrubbing tool, so we use that on our syslog servers, our old ones, and we also use it currently to process the Elasticsearch log. So we don't have too much work to do, and then it's easy to say, okay, go make me a new Logstash stack. And one sort of funny example, the last time we went to a conference, I was playing around with the Wi-Fi on the airplane, and it was usable but kind of laggy, but I was still able to, in not much time, deploy a new Logstash stack that we needed to have a test for at the time. So when it comes to upgrading, I was surprised how many changes are involved in this Logstash upgrade that we're still sort of working through. But you can create a new Git branch, which is completely separate from your production Puppet config, and we can work on making all the changes that are necessary in that branch, and then you can tell Puppet to use an environment that's pointing in that branch. So I have just been telling our test Logstash servers to use this upgrade environment, and I'm not affecting production at all. So I can work that I have been working for a month or more on getting all the changes that are needed together, and then when it comes time to deploy that to production, I'm just going to merge those Git changes into our production Puppet tree, run Puppet on the production Logstash servers, and the upgrade should be done. And like Paul likes to say, and then dust your hands and move on to the next task. And we do the same sort of thing for Banner. We have a parameter in Noodle that describes what file systems need to be created, and then we have a project we call the best for our banner systems with different roles for the database, for the app server. We have a little file manager role and one about printing. So towards the bottom is an example of what we do to create a new stack of banner VMs. And what this covers is everything that the system administrators need to do. Once this is done, the application folks still need to layer the application on top. But step one down here is use this script that we have, NSFS, which stands for new stack from stack. So it's designed to clone a stack of machines into a new one. So it asks Noodle for a stack of machines that are labeled B330. E stands for banner, and 330 is Fort Valley's school code. We're going to replace 330 with 690, which I think is Dalton's school code. So we run this and we type it into SH, and it creates a new stack of banner machines in Noodle. And then we have a tool called new, which is sort of where the VMware glue comes in. It will go out and query Noodle for whatever you specify, and then it's going to create VMs that are described by Noodle and put them in our specific ESX cluster, and then the OS install is going to start from there. So for us, we sort of step 0, which isn't here, is spend 10 minutes making DNS changes, and then we're going to say make a new stack from an existing stack, and then run new to create the OSs, and then we're done. So there's a lot of prep work involved in that, but once done, we can just crank out as many banner stacks as we need. Hopefully this shows up nicely on your screen. We had some problems when we were projecting it here. But what this is the configuration for our Elasticsearch multi-site cluster. So it's a little bit complex, and it's sort of a lot to absorb, but it's a good demonstration of how powerful Puppet is. If I were to think about what it would take to create a multi-site clustered database, I would have imagined it would be a lot more complicated. Most of what this is doing is setting parameters for Elasticsearch itself to tell it things like how much memory to use and how to split the data up among the members of the cluster. And then everything that's using a $sign here is referring to information that's coming out of Noodle. So for the that discovery line, you can have Elasticsearch discover which systems are in its cluster, or you can just tell it. And we had some surprises when we were just learning, because by default, every Elasticsearch node will just join one big Elasticsearch cluster. So we accidentally had more than one of what we were thinking we had 2 clusters, but really they were all joined together. So we started specifying, and the way we specify is basically to say, well, let's ask Noodle what the other Elasticsearch hosts are in the production stack, and then those are the ones that it uses to talk to each other. So this is a sort of a lot of information, but it's a good example that in basically one page we can get everything complete. All right, so like I said, there's a whole presentation about Noodle that I did at Rock Eagle, but I'm going to try and cover it in 2 slides. So the joke is that you use Google to search the internet, and we use Noodle to search and define our service. So here are a couple of commands. N is our little abbreviation for Noodle, and then in this case, we've asked it to show us machines that are in the DegreeWorks project and the stack 570. So I don't remember which school 570 is, but the D stands for DegreeWorks. 570 is that school. So it shows us that there are 3 machines in that project. Down below is one of these questions that we've been getting asked more and more, and that's how many resources is blah using, where blah might be a project like DegreeWorks, all of the DegreeWorks systems, or it might be a specific school's DegreeWorks stack, which is what's shown here. So it's showing you how much CPU and RAM and storage and how many OS there are. And we use this more before we had Noodle integrated with Logstash. Now a lot of this same information is in Logstash, and we can begin to give that tool to the people who are asking the question. Instead of having them have to come to us for answers, they can go look at the dashboard and get some answers for themselves. So we use Noodle for a lot of different things. I use Noodle, or excuse me, I use Emacs on my desktop to do almost everything, and I have a little key sequence that says, hey, I want to connect to a machine, and it's hooked into Noodle. So I just start typing a host name, and it will ask Noodle for the list of hosts that match that, and I can just pick from that list. We also, let's see, I'll say we have used it to generate known host files for SSH, and that's something we need to sort of finish the job with. We use it, as I mentioned earlier, with new, our tool to make new VMs, and part of the way that new works is it asks Noodle how many CPUs should this VM have, and how much RAM should it have, and how much storage. So it uses that information to decide how to get the VM set up. We also, our vCenter has a lot of VMs in it, and so we wanted to organize a little bit, so we create a folder per project. So we have a little tool that will ask Noodle what all the projects are and go create the folders in vCenter. Is Noodle still, Gene asks, is Noodle still in-house only, or are we sharing it? So I'll have to get a clear answer. I think that if we were starting from scratch today, we probably would be using something something that's already out there in the world. There are a lot more tools than there used to be when we created Noodle. So yes, the foreman is exactly what I was going to say. So there's still the open question about, hey, can we give out Noodle? And I guess the answer is maybe. I'll find out. New node from node, this NMFN is a tool that we use to copy one Noodle entry, and it came before this new stack from stack that I mentioned earlier. We use Noodle with Nagios because we have the we put the project name in all of our notifications. And yeah, so you know, oysters, and the world is your oyster. So like I said, we think that Puppet is great, and we'll get into some of the specific config examples in a little bit, but it's not the only tool that's out there. There are a lot out there, and like I said earlier, I think it's our responsibility to use more and more tools to automate more and more. I also think that that's going to help us sort of keep up with the world and stay relevant. So many of these consulting companies charge you $1 billion, but I imagine that at some point there are going to be some companies that evolve, that start using automation tools and say, you know, we're not going to charge you $1 billion, we'll just charge you $1 million, and we're a lot faster and cheaper than those other guys. So I think that in general, people who are on site and dedicated, you know, to the university system do a better job. So I think that we can use those tools. They're out there. We can and should use them so that we can do a better job, and it also helps us, you know, sort of fend off the outsourcing, which I think in the end will, you know, not work out well for the organizations hiring these external folks, and also just the customers. So here are some of the examples. Puppet is on there, of course. Chef is probably its biggest competitor. Docker is something that's fairly new in its design to, as they describe it, it's like making shipping containers for applications. So it's a way to basically take a whole application environment, including all the packages, maybe even the operating system that needs to run, and put it in a directory and sort of run it from there. So it's seeing a lot of development and use lately. Bitnami is similar to that. You've maybe heard of that, where you can basically go download either a VM or what amounts to a zip file that expands into a directory, and then you've got an entire pre-configured stack for all kinds of different tools. We've used that recently to sort of quickly play around with something. If there's something new out there, it's easy to go grab a Bitnami zip file and throw it on a machine and just sort of poke at it to decide whether maybe it's going to be useful. What else? So Chocolatey is a package management system for Windows that's supposed to make that easier. I haven't yet played around with that, but it's one of these tools that I think has the potential to make life easier. What else? Jenkins is a continuous integration platform, one of those things that can do automated testing for you. The Foreman little construction had there, it is basically designed to be your entire Puppet and OS installation infrastructure. So in theory, you go get the Foreman and you install it, and that part might be a little bit complicated, but once you've got it up and going, you sort of have a Noodle equivalent ready and a Puppet master ready and DHCP servers and other things ready, so that you can start doing everything with that system. And it's got hooked into various virtualization platforms, so you can use it there as well. And that's something that we're going to explore sometime soon as well. And that's, I guess, another point. Once you pick tools, eventually you might find that the world has changed, or for something like Noodle, it didn't really exist 5 years ago when we made it, but there are a lot of options now that we need to go out there and explore and maybe switch to. Selenium is the one with a little green check mark on it, and it's used for doing browser-based automation and testing. And there's also, of course, Oracle's Enterprise Manager. And as I told the DBAs when I was giving this presentation, that logo is only small because it's small on Oracle's website, where I spent 2 seconds grabbing all these logos. So whoever had bigger logos got the better advertising. So there are lots of tools out there. We love Puppet, but if Puppet doesn't fit for you, there's probably some tool or product out there that does. So here finally is some Puppet config. The first example shows the config required to hand out a file, fdlogrotate.com. So pretty much you just say where you want the file to go and then where you want the file to come from. That's the source. So Puppet has a file server component, and that's what the $file server part of this refers to. And then it looks in the Red Hat module for a file named logrotate.com. The default for ownership and group for files is root. So this file will end up being owned by root, and the group owner will be root. The next example is a cron job that we use to delete files from temp. So anything older than 30 days will get removed. So we have a name for the cron job, and then we define what minute of the day we want it to run, what hour of the day, and what command we want to run. And you can see it's very readable. The config is not complex to read, and it's not too complex to create. The next example is an example of a service, and this is for cron. The enable line says that you want the service to start at boot time, or it tells Puppet to make sure that the service will start at boot time. And the ensure running line says make sure that this process or this service is running, so that if for some reason cron stops running on a system, which happens once in a blue moon for maybe reasons we don't understand, it's very rare, but if it does happen, Puppet's going to come along and start cron running for us again. And this sort of thing actually helped us out recently. We recently did an Avamar backup client upgrade. Our backup guys had a way to do the upgrade from their management console. So they did that upgrade on all of our systems, and it worked great. Said, wow, this is awesome. And then they did an upgrade on some systems in the same exact way that aren't run by us. And it turned out that the backup service wasn't running once they were done. And we were at first surprised to find this because we didn't have any problems. But later we realized that probably what happened was that Puppet restarted the backup service. Even if the upgrade ended and the service wasn't running, within the next hour, Puppet came along and realized it wasn't running and started it for us. So there was a whole problem that we basically never saw just because we happen to have Puppet managing that service. The next example is for including what's called a module in Puppet. So we have created an NTP module, and we'll see, I think, all of the config for that in just a few slides. This is an example of how once you've defined something, you can tell Puppet at a high level what to do. So this just says, hey, do the right thing for NTP. And we've already defined that, and we don't have to think about the details anymore. Similarly, we currently run basically all Red Hat for our Unix-like operating system. We used to run HPUX and Solaris as well. and we may one day start using Puppet with Windows. So this include dollar operating system will include the relevant parts for whatever operating system the OS in question is running. Similarly, this last example says include the right stuff for this particular project. Whatever project this system is in, going to include the config for that. Anybody have any questions? All right, so when I went to make these slides, I thought NTP would be a good example, and I grabbed the config, and this is it. And when I was doing that, I realized that it has been a really long time since I thought about the details. And then I went back and looked at our version control, and it turns out that the last time anybody has touched our NTP config was Sam, who no longer works here, and the last time he made a change was in 2010. So this was accidentally a great example of how you can tell Puppet how to do a job, and then you don't have to think about the details anymore. I know that NTP gets set up correctly on all of our hosts, and one day we had to go and define it, but after that, it just happens over and over without us having to think about it. So I'll run through this config quickly. There's a case on the Doodle parameter project. Our name servers run time service in a different way than the rest of our hosts, and it's not managed by Puppet currently. So it just says if you're in the DNS project, well, don't do anything. And then for everything else, hand out a few files, hand out this step pickers file, hand out ftsysconfig NTP, hand out NTP conf, and make sure the service is running. One other thing that this is a good example of is how you can do some basic dependencies in Puppet. So if you look at the service, it says subscribe to file ntpconf. And what that means is that if the ntpconf file ever changes, then Puppet will first deploy the new version of ntpconf, and then it will restart the NTP service. So that's one way of creating dependencies. The next line, require package NTP, says don't try and run the NTP service until the NTP package has been installed. So you can do more and more complex dependencies in newer versions of Puppet, but they're sort of the basics, and you can see how you could extend that, and it could become, it's powerful, and you can have more complex examples of that. Okay, well, like I said, I'm out of here. That's all you need to know. So you can distribute files, you can run services and cron jobs with Puppet. It has if, then, and case statements, has reusable modules, some of which you create yourself and some of which are just out there in the world that you can use. And then we've also got Noodle, our external node database that tells what each server should have, and well, what for do you need. And of course, there's more. So there are. When I made this slide, I thought there were 1,000 free Puppet modules out there. It turns out there's probably more like 2,000 of them out there. And there's some for doing simple things, and medium things, and really complex things. So there are Puppet modules out there to install VMware's vCenter and to configure VMware's ESX. We played with those a little bit. We're not yet at the point where we think we want to use them for production, but we may well get there. And those Puppet modules come directly from VMware. They also have one for configuring their virtual firewall. Again, we're not yet using that in production, but it's an example of, well, Puppet is really powerful, and you can extend it to do a lot of things. There are definitely modules for creating VMs. If you buy Puppet Enterprise, it comes built in, and then there are some modules out there that are free that will also help you with creating VMs. Some people use Puppet to entirely manage their F5 load balancers. We don't yet do that, but it's something that we might explore. Again, it's an example of how you can do complex things with Puppet. And I think the load balancer example is an especially good example. Every time we have a banner stack, we have some load balancer config that goes along with it. Imagine if, just like when we rolled out the OS, the VIPs got created without anybody having to do any work. So that's something that's currently pretty manual process for us, but it doesn't have to be. recently played around with, there's an Oracle module out there that will install, and it will install Oracle and also create a database and make sure the database is running. So I know absolutely nothing about Oracle, but I spent maybe 2 hours playing with this module, and as a testament to how well the module was written, after 2 hours, I had a running database that our DBAs took a look at, and they said, "Oh, that's, seemed usable." And in a couple slides, there's some example of what that, or maybe it's at the very end. I have what that config looks like. So maybe that's a good way to run databases or to get them set up, or maybe there are other tools out there. It's just an example of how powerful Puppet is. There's the same guy makes a Puppet module for WebLogic, and he's got a link to an open world presentation that's titled "How to Roll Out a Complete Fusion Middleware Environment in Less than 10 Minutes," which is similar to Glue's statement about, we can deploy faster than we can go find our documentation. So those are some examples of how Puppet can be used to do complex things. It's easy to add facts, which I'll get to in just a minute. It's easy to create your own modules, and it's very easy to extend Puppet's sort of core functionality. So orchestration is something that's coming up more and more here, and we sort of wish we had already explored this in more detail, but Puppet Labs has a tool called mCollective that lets you do orchestration. And orchestration is things like, maybe for certain stacks, you need them to boot up and shut down in a specific order, or maybe you want to deploy a Puppet change into your Puppet config and then tell all of your systems to hurry up and go execute against that new config, things like that. So we're planning on exploring that soon. And there are also, of course, other orchestration tools out there. All right, so here is what the Puppet architecture looks like. And this slide is mostly stolen from Luke, who created Puppet. If you follow the spiral around by the numbers, the node here represents an operating system. And the first thing that happens when you run Puppet on that node is that it will gather facts about the operating system. It will figure out, for one, which operating system it is. It will figure out how much CPU and RAM is in the system, what file systems the system has, how the network interfaces are configured, and a bunch of other stuff. The tool that does that is called Factor, and it's similar to Puppet in that it's extensible too. So Factor comes out of the box with a bunch of facts, and we've added probably 10 or 15 facts of our own. It's pretty easy to write a little bit of Ruby code and get some more facts about all of your systems. And that's a pretty powerful tool. There have been times where we've discovered a problem and we wonder how widespread the problem is. And so what we'll do is write a fact to collect information about it and just wait for Puppet to run on all the systems and report the facts back, and then we'll go take a look and see what things look like. So the node gathers the facts and it sends them to the Puppet master. The Puppet master uses those facts plus what's in the external node classifier, which is Doodle in our case. So it takes sort of those as variables and it uses them with the Puppet config to create a catalog. And the catalog is basically a to-do list that it hands back to the node, and it says, here's a bunch of resources, and they should be configured in this specific way. The node gets that catalog back, and then it executes. And the way it executes, it will put things in the right order as far as dependencies are concerned, and then it will go through each resource and check whether it's already the way it's supposed to be or not. And if it is, if it's already the way it's supposed to be, it won't do anything. But if it's not the way it's supposed to be, it will go ahead and change it so that it is. And then let's see, number 3, the node, once it's done, will send a report back to the Puppet master about the things that it needed to do. And there are various report collectors that you can use. They accumulate on the Puppet master, and then you can also use various tools to look at them. So when I drew in these boxes about Doodle and Logstash, because we have Doodle is its own database where we define projects and parameters about our system. And then since Puppet is already collecting all these facts, we wanted to get them into Doodle too, because Noodle for us is easy to query, and it's nice to have all the data in one spot. So it was very easy to go get this data from Puppet and put it into Noodle. So it's a good example of how tools that are extensible and have APIs and so forth make your life easy. Similarly, Logstash, it's fairly easy to create an input for Logstash. So I made one of those that just reads data from Noodle, and that's how we got those dashboards that you saw towards the beginning. All right. So here in more detail is what Puppet does for this example config where we're handing out logrotate.conf. So this little stanza says, make sure that the file exists and make sure the contents of the file match what's on the source. And like I said, the default for ownership and group ownership is root, so it's going to make sure that this file is owned by root. And then the default permissions on files are 0644. So write for the owner, read write for the owner, and read for everybody else. So the Puppet client will get the catalog from the Puppet master and resolve the dependencies. And for this example here, it's going to check and see whether logrotate.conf exists, and then check whether its contents match what's on the file server in Puppet. And then if it needs to, it will fix it. And otherwise, it'll just move on to the next one. Right. So this just describes in more detail how you can do, or it's really just more examples of how you can create dependencies of it. And there are more and more dependency and order mechanisms in the Puppet configuration language. So they're not all listed here, mostly because I haven't explored all. Alrighty. Yeah, so we have talked on and off about making how we could perhaps help the DBAs with Puppet. We like to use it a lot, and they've sort of asked about whether they can use it too over the years, and we've never really had a great solution for that. So recently, Puppet Enterprise in its release note said, hey, you can use this to maybe give to your DBAs as well. We sort of looked at how that works, and it turns out it works in a surprising way, which is basically to create a whole separate Puppet stack for the DBA. So that's something that we're going to explore in the next month or so here, is create a Puppet stack and give control of its config to the DBAs and just have them play around and see if it's a tool that can be useful for them. So it's one of these, maybe we can all work together with this particular automation product, or maybe this will at least, show them how automation can be helpful, and maybe there are other tools that will work for them. So it's something that that's interesting, and I guess we'll have more to say about it in a few months. Alrighty. So, like I said at the beginning, I don't think that there are any. There's no reason not to use automation tools anymore. Just like there's no reason to have a website that looks ugly or is not responsive. There's so many tools out there in the world that we have to be using. There are especially a lot of open source and free tools, and there are new tools that come out every day. It's true that it's a lot to learn, and each new tool has its own learning curve, but I think that you get a lot of return on your investment. I think Logstash is really helping me to see how these tools can really fit together. It was really fast to get data from Noodle into Logstash, which gives us sort of a dashboard experience that we've only been wishing for before now, and now it's sort of there, and Logstash and Kibana are so powerful that all this data that we've had and been using is suddenly a lot more accessible. So the more tools that you've got, I think the more that they build on each other and combine to work together. So it's like, the other thing I want to say is it's complex, but it's not complicated. Down at the bottom is a little definition that I stole from somewhere that I think is scrolled off the screen, so I would say. But basically, it's trying to say that if a problem is complex, it has a lot of components, but it doesn't necessarily make it more difficult. So I think complicated Yeah, that's like a cool down. Yeah, sorry about that. In any case, the bottom line I think is complex is good and complicated is bad. Complicated is sort of what we ended up with when we were trying to do everything by hand. And for example, the example Peter used about trying to keep the UIDs all the same, well, it turned into a complicated problem because they just weren't the same. And then it was hard to reconcile and get them changed. We had too many that were not the same to go and make some sweeping change without sort of shutting everything down, making a bunch of changes, and then bringing it all back up. So hopefully what you get out of using a lot of automation tools and products is complexity and not complication. All right. So does anybody have any questions? Anybody? I think that's all I've got. I can show the Oracle database config if anybody's interested in that. But otherwise, that's all I've got.
Thank you so much, Mark. Does anyone have any questions? Any of our participants? Scrolling down the list to see. We do appreciate everyone's participation today, and feel free to shoot me an email if you want some further feedback from Mark if you think of any questions after the fact, and also if there are other things that this group could present to you that you're interested in, shoot me a message and we'd love to connect with you guys. So anyway, we appreciate your time today, and
One question.
Brian on our team has a question here.
So Dalton asks about security. Here is the main server handling of it.
Oh, well, I guess I failed to mention it on the picture of the architecture from Luke, but everything is SSL encrypted. So each client gets its own SSL key, and then the server manages those keys. And so the client and the server have to agree, that the server is trusted and that the client is trusted. So there's a process that you go through when you add a new client, where a new client can try and talk to the puppet master and basically creates a request to be allowed to come in, and it sends in its public key. And then on the server, you have to make a decision about whether you're going to let that new client come in or not before it will be able to get anything out of the server.
Gene has mentioned here, you wouldn't mind seeing the Oracle DB config.
Oh, yeah, sure. So this first page is showing just the database installation. And this is basically cut and pasted from the website. If you search for Puppet and Aura DB, then you'll find this Puppet module. So this is pretty simple and easy to read. It's saying, well, it's version 12.1.0.1 of the database. The module has you download basically the .zip files from oracle.com and put them in a place that it can get to. And in this case, it's specified by this Puppet download mount point variable. The database type is Enterprise Edition. You can do, I think the other choices are Standard Edition and maybe one other one. You tell it where you want to install Oracle, whether you're going to create the Oracle user or not. And that's about it. So that's what installs the Oracle database software. And I have no idea what net 8 means, but it was one of the requirements. So this stanza on top does that. And then the stanza on the bottom gets the Oracle listener run. So again, there's not a whole lot that you have to tell it. And things like this Oracle base and Oracle home, they're specified multiple times in this config. But if we were really doing this in Puppet, we would either have this coming out of Noodle as a parameter, or we would define it one time in our Puppet config so it doesn't need to be repeated over and over again. Same for the user and the group. In Puppet, you can create what are called overrides, which are maybe another way to say it is to create a default. So you could create a default for a DB listener, and you could say that, well, the user is always Oracle and the group is always DBA. So you wouldn't have to specify it every time you wanted to have it. And then I think there's one more page. Here's the page that creates a test database. And again, I don't know a whole lot about Oracle, but it's not too hard to read this config and see that it's setting some parameters, and then what we got out of this was a database. So that's what that looks like. Anybody else with questions?
Okay. Dan, we do appreciate your time, and we've enjoyed being with you guys today. Please do feel free to contact us if there's any other sessions that we can bring your way that you're interested in, and we'd love to connect with you all. So thank you again for your time today, and we've enjoyed it very much. Thank you.